Here is a great question that I want to work out today. I kind of found that it's very interesting because this question is not easy. And obviously, there is something that students would usually miss out in this question. So, here is a rod, a vertical rod, and tied to the rod, you have a string. And so, the string is tied in two parts. As you can see, it's a string. And here is a bead, a very light one, 100 grams. And the vertical rod is rotated at a great speed. So as it rotates, this part of the string becomes horizontal, and the distance here is 0.3 meter. This distance is 0.4 meter. And you're asked to find the speed at which the bead rotates. So that's the question. So these distances are given. So let's say AB is 0.4 meter, BC, if this is point C, is 0.3 meter, and that makes this distance 0.5 meter because you have a right angle triangle. So how do we find the velocity with which the bead is rotating? Obviously, this is making a circular path, so there is a centripetal force that's acting on the bead. And there's also tension in the string on this part. And here is the free body diagram. So you have the tension in the string on this part, and since it's the same string, the same tension also acts in this part. And this is the weight of the bead, mg, which is 0.1 times 9.8. Because it's 100 grams, it's 0.1 times 9.8. So that is the free body diagram. That is the weight, which is 0.98 newtons. And then you have tension, the same tension in the string. And to solve this question, we have to resolve this tension into its two components. So if this is theta, you're going to get this as t cosine theta and this as t sine theta. Those are the components of this tension. Now we can find theta from the triangle, and using that we can also find the tension. So there is the centripetal force acting on the bead because it's making a circular path, and centripetal force is mv squared by r. And now from the diagram we can see that t sine theta is equal to mg. T sine theta should be equal to mg. So t sine theta is 0.98 newtons, from which we can find t, because sine theta is opposite side by hypotenuse, which is 0.4 by 0.5. So we can do that math and find the tension to be 1.225 newtons. So once we get the tension, we need to make sure that the total force which provides the centripetal force is actually t cosine theta plus t. I hope that makes sense, because you have t cosine theta, which is the component of this t, and you also have the same tension acting in the horizontal part. So the total force here is t cosine theta plus t, which together is equal to mv squared by r. So 1.225, which is the tension, plus 1.225 cosine theta. Again, cosine theta is 0.3 by 0.5 from that triangle. So when you substitute that, and you have the radius as 0.3, now from that equation we can solve for the velocity of the bead. And you get it as 2.43 meter per second. That is a good question. I hope you understood how I worked out this question. Thank you.